Hi, this is Alex with another episode of the Connected Factory podcast, and I have today a very special guest with me, Rick Bullotta. He is a serial entrepreneur and founder of one of the most influential industrial IoT software pieces, Thingworx. So let's get into the trenches and let's hear it directly straight from Rick. We're excited to have you today here, Rick. Like just phrasing your LinkedIn from barely graduating college, then founding two successful companies. Can you elaborate on that?
That's it. I added that later, but I joke with people though, and this is legitimate that to be successful, I think in any pursuit, it's not just technical skills. It's not just great product and all that kinds of things. And perhaps it's the social skills that I developed in university that have helped me a bit along the way. But in retrospect, I probably wish I paid a little bit more attention in college, but nevertheless. I think a well-rounded set of skills is essential to be a startup founder, as I'm sure you're finding.
Yeah. Did you majoring in engineering or IT? What was it?
Yeah, so I started out as a mechanical engineer, and I was sitting in a lab one day looking at a piece of broken metal under a microscope and said, "This is not for me." I actually switched to in a way more quantitative. It was operations research and industrial engineering. So a little bit more mathematics oriented, supply chain, some elements of that. That's where I
fully agree. I think mechanical engineering also lost me when they said, okay, we have now a piece of steel here. Let's now pull on it for 5 years. Let's see what happens. It was like, wow, this is quite boring. Irrelevant, don't get me wrong, but not for me. So I was also then going more production.
Ironically, I ended up in the steel industry. So cutting out pieces of steel to have them go be tested by mechanical engineers.
Yeah, actually, yeah. We also, one of our first projects was also actually in the steel industry. Actually quite random because the industry is not seen for being innovative and high margin and digital, but a lot of learnings. What do you actually do in your spare time? If I see you on LinkedIn, it's also a lot of biking, being outside. So you enjoy your well-deserved post-funding. Yeah.
If it has two wheels, I probably enjoy it. But my wife and I are very much into mountain biking, skiing, snowboarding, things like that. So I try and take advantage of those opportunities.
Oh, it's nice to get outside. Perhaps I still need to get to that point in my life to be again outside and not in the office all day. But
well, in a way, I think I've kind of been able to get to a great spot in terms of through advisory work. I get to be involved with the technical fund, the business development fund, but I can get away, right? It's a more part-time engagement. I will say I tend to be a bit more active and hands-on as an advisor than your typical kind of advisory board roles. And it keeps me intellectually challenged. I'm doing a lot of research stuff. I've got a little robot PLC and some other toys here, but lately a lot of stuff around AI and LLMs and, basically constantly trying to learn.
Yeah, this is actually, I think, the key to don't stop learning and don't also like be true to what you really believe is. So like engineers also tend to reinvent the wheel a lot of the times. So like specifically if they try to program stuff, this is, I would say, a dangerous place to be in, specifically considering like the German councils and the foundations, and like they think about like we know everything better, but there is also like an IT world out there that you could also tap into and learn from them. So yeah,
I have a lot of experience in that world as well, because I don't know if you know, in the mid 2000s, I used to work at SAP Research. So we were doing a lot of EU funded projects. In fact, a lot of what we did at Future Factory Initiative in Dresden was directly related to the founding of Industry 4.0. If you recall, our CEO, Dr. Kagerman, was integral to the whole original Industry 4.0 initiative.
Was it after you? So you perhaps for the audience, you founded like an MES company like super early on. Then you sold it to SAP, right? And this was then the after, like the
right. So
the integration process.
So yeah, in 2005 we were acquired by SAP. I was involved with, it was actually a little bit more than an MES. It was kind of, it was called SAP MII, Manufacturing Intelligence and Integration. So in a way, it was kind of a UNS, right? It was bringing together all these disparate sources, letting you build applications, composite views of them. And then we realized that if we have all this information aggregated together for people, we can share it with other systems. And that's what got SAP's attention. We can now populate, other applications with real-time data. And then SAP Research, the team there was called the Future Factory Initiative, doing some really cool stuff ahead of our time around additive manufacturing and RFID and indoor positioning and all kinds of cool applications. Then we moved beyond that into kind of what's the potential when you integrate the physical world with anything, with healthcare, with public safety and security, manufacturing, and that, so we learned a lot along the way there about the cybersecurity implications, the challenges of all the diverse set of things you need to connect to. But that was a really enjoyable time in my career. Great, and got to do a lot of fun travel as well.
Actually, back then it looks quite crazy. Like all these things that are still new now, or like in the vast majority of industrial companies not yet implemented, having that 20 years or whatever, like back
More
then
than
already.
that, it was a very
Crazy,
long.
crazy. I'm not sure what I have been doing back then, but this is actually crazy. Was then Thingworx a little bit a logical consequence, because you're saying like the MII was like building applications and integrations, and then Thingworx was like making that even more accessible, or how did you?
Yeah, two things. Actually, it kind of grew out of that whole what we called real world awareness. So my background obviously was very much in the factory setting, right? Connecting or utilities, some of that as well. And then we basically this work that we did at SAP, it gave me the idea that well, these same challenges exist in other industry verticals. So how can we build platforms? Ultimately, every new initiative, the Internet of Things, whatever you want to call it, one of the key opportunities is to build the tooling so that other people can build, domain specific applications. And that's always been my background, whether it's from, Wonderware to Lighthammer and ThingWorx. They really were all tools and platforms to let other people build applications. So the idea was, can we have a platform that would serve both the industrial IoT market inside the factory and the connected everything Internet of Things? In retrospect, we probably would have done that a little bit, split them up a little bit more, but that was kind of the genesis of what we did at ThingWorx.
I think this is actually like the essence of building good software in manufacturing, is always this upskilling aspect. Like you have like these business problems in manufacturing that are super unique, and only like the engineer on site level knows how to solve
Yeah.
them easy, but he doesn't know how to program. He doesn't know how to build applications. The UNSs, he doesn't know how to get data effectively and scalably. And I think providing them tooling is key. And yeah, so
That's
like,
I think we see that with any new technology, right? Think of the applications of AI and generative AI, and even for more kind of traditional examples, like let's think about how many engineers come out of university now and know how to program PLCs. It's a very small number, right? Do automation work. So there's in fact, I had this discussion with someone just yesterday. There's an opportunity for a whole new way to configure these kinds of systems. Like my vision was always, you should be able to take it from the original design and simulation. You're designing a new facility or line or process or product. You should be able to take it directly from design to simulation to why not be able to hit a button that generates 80% of the application for you. Use those same simulators to train users, to train AI. So there's this convergence happening now of all these different technologies. Pretty exciting time to be in the industry. But ultimately, to your point, we've got to find ways to democratize applying this, meaning you don't need to be a specialist in 10 different technologies, whether you call it low code, no code, high level languages, platform, whatever those terms you want to use, it's got to get easier.
I also think this removing this specialness about manufacturing is also super important. So let me elaborate. Like in manufacturing, we tend to reinvent the wheel from databases, programming languages, like programming PLCs could also be on a microcontroller or like compiled code basis. And now we have like this new stream of technologies, everything CI/CD pipelines, like who already dominate like the IT world, and we have AI for code gen. But if we are still on the ladder logic way of doing things, there's not enough code base to actually get that running. So creating a common ground on technology, this is also what we like: SQL, MQTT, Kafka, like IT, but for OT applications. Yeah.
I think we could tie this back to your comment on who's doing these developments and what their skill set. I think what a lot of people forget is that ladder logic was an evolution of hardwired relay lot, right? So it was electricians used to do the implementation of these control systems or deeply involved in them, and we shifted to a more digital model. Although yes, there's some we'd love to have less uniqueness in what we do in manufacturing, but the fact that these are truly mission critical, that if the system fails, people get hurt, the environment gets damaged, there's economic damage. I think that is a little bit different than a social media site or a pet food, pet purchasing.
But this is also super interesting point, because they're also aligning needs to work is also super strange. Like if you ask like a Kubernetes expert running like Google, he will say we know never 100% availability. We're currently cracking hard on the fourth 9 after the digit. And if you would ask like an SCADA engineer or like a factory IT guy, no, our systems never fail. They cannot fail. They're designed to not fail. And this is not possible, Misi, but it's also how they think different. Like failover, like hardwired. If one application dies and it cannot reach the other application spawns. And in a Kubernetes sense, you would model it super differently and super interesting.
I think there's some mythology too happening now with that Kubernetes and similar technologies will solve all those problems, right? The reality is that the containers, the pods, the software that's running in them needs to be designed around highly available, scalable. You just don't
real time. Yeah.
Exactly. The infrastructure doesn't magically make all that happen. It needs to be designed.
Yeah. I think there was also a good, like actually the real-time patch, like this PLCs are designed like to be compiled real time and guarantee you like deliverability of the code. And actually this was 1 year ago or 1.5 years ago when actually the main Linux kernel was patched this real-time stuff into. So, and this was actually a good Corona side effect. The whole supply chain was broken. You cannot get a Siemens PLC, so everybody needs to have like virtualized PLCs. And this was, I think, a good push. But yeah, not everybody is yet there.
Yeah, I think most of that initial effort around virtual PLCs is probably going to take much longer than we think. Now, it's excellent for testing, right? Test simulation development, fantastic approach. In production, for a variety of reasons, I think we're a little ways away from that.
Yeah. There are also like surrounding technologies that needs to be like real-time compute. Okay, we have it now, but real-time Ethernet, for example, like there's also like needs to be guarantees on that level. And there's also like humongous change cost to something like that. Yeah, everybody's trained on Siemens, trained on the hardware, trained on the supply chain. Yeah,
it's interesting you say that because one observation I've had with a lot of the startups that I work with, a lot of times they'll talk about the challenges that they're facing getting their customers to scale their deployments, just to scale up, and not technical scale, just to roll it out to multiple sites. And I've realized it's not a matter of money. It's they can find the money. It's the time. Can the customer devote the resources? Can they devote retraining people on a new technology? These are really obstacles to run out new things.
This is actually also why software manufacturing needs to be 10 times better to be changed. Like, I think a good example of this is like Pi system, OZ Pi. Like, they also now go to Wonderware, Historian in the cloud, etc., etc. But this is just, perhaps I don't make friends with that, but an overpriced database that has no technical relevance to exist. But like people are trained on the APIs, people have spent millions on system integration, so they will not change. And yeah, you now need to be 10 times better.
There is another element to that. Like I hear a lot of discussion about the next gen historian. Like what does that look like? And the data store is just one part of what a traditional historian does, right? We still need that last foot or last meter of connectivity. You need to be able to talk to the hundreds of different things that you have out in the field. Secondly, you need that domain specific user experience that allows a non-technical person or a process engineer to, to let me compare these things, aggregate them without, writing queries and things like that. So next gen historian is going to require more than just a good time series database.
Yep, yep, yeah. It's way more, but hopefully, like the UNS is actually an enabler for that. Like you solve the connectivity once, create the data structures on the event basis, and then just get it in there, and then min, mix, average, moving, whatever you can do then on the time series database level.
In a perfect world, and we've had some discussions online about this, I really don't want to have to go to two different systems, one for current state and one for the historical
Uber
exhaust.
broker.
Right,
Yeah.
exactly. Well, or some, whatever that we want to call that, yes. But the
Yeah.
idea is that it can become that single, what do you call it? Single surface through which I can access all that information. I can security management at one layer. I can have one namespace. And even if sometimes the UNS or
Yeah.
whatever is collecting the history, sometimes it already exists in some other existing system. That's the other unique thing about manufacturing, right? When you're starting up some IT initiative for a new order management system or inventory management system, typically when you make the switch over, it's 100%. You don't have as much legacy to deal with and legacy to connect to. Maybe some legacy, integrations with other trading partners, but in our world, legacy is real, right? You get equipment in from OEM suppliers. You have lots of this legacy that it really does change the way we have to implement systems, and we can't just ignore legacy and duplicate it in a pharmaceutical environment. You wouldn't do that, right?
Yeah. Not allowed to copy. Yeah. Yeah.
So a lot of implications.
And how do you see like the role of the IoT platform? So like when we actually started as a system integrator, like before UMH, we actually implemented Thingworx like as one of the OE dashboard, get me predictive maintenance, etc. How do you think it changed over the last 7-8 years? What it's focusing on, or did it change
Didn't
at all?
change enough. I mean, that generation, I mean, those types of products were very unique and powerful. I mean, if you look at, let's face it, we're all byproducts of the things we've done in the past. So if you look at Thingworx, it had elements of SCADA and HMI systems. The way you did, scripting and event handling was very much like, Wonderware or something like that. It had elements of what we did at Lighthammer and compose, an API to browse data, to get data, to UX components to build applications. But since then, there's been a lot of innovations that should be leveraged in future IoT platforms.
Okay.
Generative AI obviously being one to help automate the configuration, modernizing a lot of the technology components, new ways to deploy, containerization, new ways to deploy these things, flexible data storage. So there's lots of room for improvement. So to the startups out there, like in companies like UMH, go for it. The
Yeah,
opportunity's still there.
there's still the need, and I think if I would now phrase like how IoT platform should be, don't do persistence, don't do data handling, just be this low code, no code application builder on top. So
Yep.
perhaps controversial, but but Grafana is for me an IoT platform. Could be perceived as one. You can consume there, you can perhaps also, if there's a great open source business panels, you can also push data there.
Yep.
But this is a key need, and also
I have the main issue I have with Grafana, two issues I have with Grafana. To me, real value gets unlocked when you make things actionable, when you can, do human data collection, interaction, rules-based, execution of things. And Grafana is really not a very good platform for environment for that. It's excellent for visualizing. It's also not very great for cross data source drill downs. You can do them, but a little bit, it's more than a little bit awkward to do that. So, but if you're just trying to gain operational visibility, it's a fantastic tool for that.
Yeah, yeah. And I think it's also great for tools in OT environment where it's also designed for IT environments. So like it's
Yep.
for everybody else, there's normally IT tool to monitor servers and software applications. And if you think about the factory being an application, you can also monitor it. Yeah, you can do alerting, like a Teams message, a phone call, an
Yep.
email. Like if one of our customers, they have like a water basin, and if it goes empty, they get a Teams message and things like that. Really, really powerful, but I would fully agree it's not designed to be actionable, like doing stuff, drill down into, or like it cannot be a good OEE board because like you really want to drill down into quality or in availability. But
It can be done, but it's
yeah,
awkward. And I'm seeing, I think we've evolved it even in the AI domain. One of the companies I work with, TwinThread, is now getting to the point where they're completely closing the loop. So it's running the algorithms, determining what the optimal settings are to achieve some certain type, quality or throughput or energy, and writing them to the control level or the
yeah.
SCADA level. That's a big step, right? When you're moving, and that's kind of I think the question with AI in general. When do we go past human in the loop?
What is your favorite AI use case that is currently productive? And I just like this industrial co-pilots and uploading your handbooks. Okay, I seen it, but what's your favorite one?
Yeah, three main ones I think are, we've got to get past the Gen AI is the only kind of AI. Really, actually, I'd say there's four. So, generative AI in two ways: to be a co-pilot for an operator, knowledge, best practices and documentation. Generative AI for the automation and system developer to make them more productive. AI for what I call meta sensing. So that's where you're using vision or vibration and applying algorithms to get some other insight to that. And then the AI for actual predictive and prescriptive closed loop control. Those four areas together is really where we're going to unlock the value.
Fully agree. I think most corporates just went the rabbit hole of large language models and poured billions. But yeah, I think this was perhaps a little hot time this year. Let's see how it actually unfolds next year.
Yeah.
And what do you see differently? You're active in mostly in the US, but also in Europe, obviously. And what do you think is a difference in the industrial software landscape, like the
I think it's more generically the kind of a startup and software landscape, right? There's it's a natural conservatism, the way investment can happen, the way adoption happens. You could argue that a lot of the European companies actually focus on substantive, high quality software versus marketing hype.
yeah.
So there's good and bad of both approaches. I'd love to see kind of both merge together, right? I would say there's no shortage of very, very smart people in the world that can create great stuff. If I've learned anything over the years, that the hardest thing of building a new company, of course, the product and getting it right is important. It's building the go-to-market aspects. I mean, whether some people find it like, oh, do I really have to do that? Well, yeah, you do. Unless you can sell software, unless people know about you, then it becomes just a science experiment.
And it goes also hand in hand with building a better product. It is not either or, like building the best product out there and then it will sell magically, or building nothing and just selling on hype and vision, then it will also fall apart. Actually, we got investment early that year, and before that, thank you. And before that, it was actually like super inbound driven at UMH. Like we just executed on the leads that we actually got into. But then as we like now structurally go out there and force people to talk to us, if you want so, actually
Yep.
we increased active users multiple times, orders of magnitude, and everything gets faster. It gets also clearer on what to develop. Like if you have like a handful of users and customers, you can do that. But if 80% say that, and not only like two people, this is also like, it gives you sharpness and focus that you would not have before. And it is also why we open source, yeah. So we can ship software to many people that we don't need to go to the go-to-market hoop to get their feedback. And perhaps,
as you know, I'm a passionate believer in openness. Whether it has to be source or not, we can debate. But any product that doesn't have rich APIs, open data, as a buyer, I would never consider
yeah,
something that doesn't offer that. The second piece is extensibility, right? If a platform, I always felt like by offering good extensibility in the products we made, we allowed our partners to add value. We also allowed our salespeople to basically always say yes. Like, can it do this? Certainly it can. You might have to develop a little bit of an extension or an add on to do that, but it allowed us to access a much more broader market.
yeah, being more
So,
flexible also on the use cases without making a monolithic software piece by saying that yes, and needed to build and maintain it, you can do it through an integration or like customization on the outside. Yeah, that's super, super good. So actually looking a little bit on the clock, we like nearing the half-hour mark with the golden hour, but perhaps one last thing. What do you think is the next wave? Like you have the AI, like where will be companies produce like special agents, special use cases, but what still annoys you most in an industrial setting where it needs to be a tech next?
I still, what annoy might be a strong word, but what frustrates me, or maybe the opportunity, goes back to what we were talking about a little bit earlier. I see all of these as just enablers, right? AI is an enabling technology, industrial IoT platforms, data stores, low code development environments. Is when we synthesize those together to build useful applications that value gets created. So we need to stop focusing on the individual pieces or whatever is hyped that week and enable people to rapidly compose applications from these pieces to insulate them from the complexities and the difficulty. AI in its many, like we talked about, the many dimensions is going to have a profound impact over the next couple of years. But it's only going to happen if the platforms to make it much easier to adopt come to be. We're going to see a lot of I'm learning more and more of the importance of simulation. And this is a very difficult problem to solve. But think about like today, if you were going to train a machine learning model on an existing process or existing piece of equipment, you're going to go to some historical data archive or archives, ingest that data, shape it, train the models. What if you're trying to do that for something completely new equipment, a new process? You can't. So one of the approaches is to build rich simulations that are first principles driven, physics, chemistry, biology, the dynamics of the process. That's really hard. That's very, very difficult to do. But it's an essential enabler for this vision I have of going from design to simulation to implementation for new processes and equipment and machines and new anything. So I'm hoping that we'll see you've got a lot of work going on, like with Omniverse and other stuff that's very tightly focused on some relative, almost gaming oriented physics, right? And motion physics. And that's a small subset, but to simulate an industrial process in food or beverage or chemical, it's a whole different set of things that we need to be able to model. So that's an area I think needs investment. Could have some big payoff as well.
Definitely, especially also looking at the labor shortage on the automation side of things. They cannot build anything, perhaps simulating upfront and then narrowing down the development efforts. Super, super important.
I would guess that 80%, 50%, some sizable percentage of what we do in industrial automation and control is cut and paste. A motor starter, a handoff auto control for a push button, a sequencer. These are all well-known building blocks. So how do we build that almost? I'm not going to say the no-code environment, but the low-code environment for control that automate. And there's some folks working on that problem in specific domains today, where you describe it at a much higher level and it writes the code for you, or writes as much of the code as it can. AI, it doesn't always need AI to do that, but it's going to be boosting the productivity of the people that are trying to. And it's the other thing that I think we lose sight of it's not just about developing new applications and new processes and new machines. There's I'm sure many of your customers are focused on continuous improvement, getting the most out of what they already have, better energy efficiency, better throughput, better quality, right?
Yeah,
So it's we really have to serve both of those scenarios.
definitely. Definitely. So was as expected, really, really nice to talk to you. So this will be the last episode of the year. So everybody already great Christmas break and a
You as
good
well.
happy New Year. And Rick, thank you. It was
My
a pleasure.
pleasure. And have a wonderful holiday, everyone.